This lesson is on section 6.3, solving multi-step inequalities. This is the section I'm choosing to review with the intermediate class about solving inequalities. The first two sections talk about solving one and two-step inequalities, so we're going to jump, I think we can do those. We're going to jump right to section 3 where we're solving inequalities with more than one step. Inequalities, remember, what does the word inequality mean? Well, we're talking about, you can see the word equal in there. Remember, the prefix in means like not equal. So usually students, after I kind of mention or remind them that if they break down the word like that, they can think of, okay, what kind of things are we talking about? What kind of expressions or equations, or what are we talking about with things that would not be equal? Well, when they're equal, we got an equal sign. So if we're going to talk about something that's not equal, we could put a slash through it. That is one inequality to show that the two sides would not be equal. But the other ones we can usually start to come about as we talk about it are these signs that we see quite frequently. These are the inequalities we're going to talk about. And that first one is greater than. The second one is less than. And then with the lines underneath, when I have a line underneath each one, that just means it could be equal to both sides. The left side could be equal to the right side. So greater than or equal to and less than or equal to. So these are the four main inequalities that we'll talk about. The nice thing with inequalities, as we'll see, is we can solve inequality problems just like we solve equation problems. They're the exact same type of steps. There's just one kind of glitch that we'll have to keep an eye on, but otherwise the steps are exactly the same. When it comes to representing the solution to an inequality, remember that an equation has an equal sign, so we get some kind of answer like x equals 5. Well, with an inequality, we get something like x is greater than 5, or even greater than or equal to 5. So in this case, we just have one answer that's a solution. In this case, we have an infinite amount of answers that are solution. It can be any number that's greater than or equal to 5. And so to express that, often a visual way to do that is by showing a little number line graph. One reminder I'll give students right now, and usually they can kind of pick this up and remember it too. When we're talking about making a number line graph, when we're talking about the solution or the situations where we have greater than or less than in our problem, the graph will include an open circle, if I can spell circle right here, an open circle on your graph. And when I have greater than or equal to or less than or equal to, I'll have a closed circle when I'm making my graph. So I'll show what these look like here in just a second as well, but just something to jot down if you're taking notes along with me. I do want you to have these inequalities down, and then one thing to note with them is open circle for those top two when you're graphing, closed circle for those bottom two when you're graphing. Again, the section title says solve multi-step inequalities, so we're going to solve them, as I'll keep mentioning to the class. It's just like solving equations. So here's an inequality problem. 5x is less than or equal to 35. It's just like solving the problem 5x is equal to 35. That's the nice thing about inequalities. We don't have to learn any type of new steps. We can use the steps we learned over here and apply them to inequalities. So in solving an equation like this, I would divide both sides by 5. The 5s would cancel here, so I'd end up just having x equals and then whatever my solution is, well in this case 7. So x equals 7 for my solution there. For the inequality, same steps. I'm going to divide both sides by 5. So I get x is less than or equal to 7. Again, here's the difference. In an equation, I just end up with one answer. X equals 7. That's the one problem. That's the one number, I should say, that I could plug back into the original equation and make that equation true. With an inequality, x is greater than or equal to 7. It's saying I have a lot of different answers. In this case, anything 7 or greater, I can plug back into the original inequality, and that would make the inequality true. Or sorry, actually, I'm looking at less than. Well, x is less than or equal to 7, so I think I was saying that wrong, but it should be less than or equal to 7. So any number that's less than or equal to 7, I can plug in and make the inequality true. What does a graph of this look like? Well, 7 is our key number, so we're going to go there and have a circle around 7. And like I mentioned in that previous slide, if I'm talking about less than or equal to, in this case, if we have less than or equal to is what we're looking at, then we're going to have a closed circle. We're going to fill in that circle. Why do we do that? Well, in general, when we're grading, we're going to shade in all, or when we're graphing these, we're going to shade in all the possible answers. So if it's less than or equal to, we're saying that x could be equal to 7. So we're going to fill in that circle because that's one of our possible answers. And then if we're talking about all the numbers that are less than, we're going to shade to the left. Now when I show this example up here, I happen to have this number line with a bunch of numbers. As I'll tell students though, you don't have to have that many numbers on your number line when you're making these in your homework. You can just make the key number 7 and then some numbers around it. And if I can do the same thing here, close circle on 7 and then just shade to the left, this is all you really have to have for your number lines. You don't have to have anything with like 10 different numbers on there, just the key number and then which direction we're going. You do need some numbers around it because you do have to show which way, left or right, are the numbers getting smaller or are the numbers getting bigger? Which direction are we going? There's nothing that says the small numbers have to be on the left. So you do have to put some other numbers in there to designate which way you should go. Just showing a few more examples here. This next one says t divided by 5 is less than -8. So on this one, I would have to multiply both sides by 5. Again, just like solving an equation, the steps are the same to get the variable by itself. When I multiply both sides by 5, those 5s will cancel out, and I'll get t is less than -40. So this is what a problem might look like for you in the homework. I would find that solution, solve that inequality, t is less than -40, and again, then I could just say -40 is here, put some numbers that are nearby -40, like -41 and -39. In this case, it'd be an open circle, and I would shade to the left. I want all numbers less than -40. I have number 3 up here, though, for one other important reason. So a couple examples, but number 3 is a more important example. There is, again, as I mentioned right at the very beginning, inequalities solved just like equations, which is very nice. We can use all these same steps. But there is one glitch that happens with inequalities that we have to keep an eye on, and it happens in a problem just like number 3 here. So I'm going to start solving this one just the way I would for any other problem. -7x is greater than or equal to 98. So I'm going to divide both sides by -7 to solve it and get x by itself. So x is greater than or equal to, in this case, well, let's see, I would have, I think, -14. So x is greater than or equal to -14. If I make a number line, and I'll make this one a little bigger just to kind of show my point. Here's -14, -15, -13, and some other numbers I can keep going down the row too. I'm going to have 0 over here just to show my point as well. But what would this look like? I would close circle on -14. And I'm actually even going to do it in a different color just to show it. But I'm going to close circle on -14. And I would shade to the right because I want all numbers that are greater than -14. So, given what we've been doing earlier, this means that I should have shaded in all the possible solutions for this inequality right here. X is greater than or equal to -14. There's one glitch, again, that happens with this type of problem. Look at a number like 0. Okay, so I shaded in the answer of 0. So that means 0 should be a possible solution. Let's put 0 in, though, and see what happens in this inequality. -7 times 0 would give me 0. And it's telling me 0 is greater than or equal to 98. Is that true? Well, no, it's not. That's not true at all. Okay, so something happened here when I solved this inequality. I'm not getting the right answers. I could plug in other numbers here that are over here too. I could plug in, again, something like, here's -1. Okay, if I plug in -1 into this problem, -7 times -1 will be +7. Is that greater than or equal to 98? Okay, no, that's not either. So again, something's happening with all the answers that I supposedly shaded in as the right answers. Here's the trouble, or here's the one situation we have to keep an eye on. In an inequality problem, I'm going to erase all this and go back to the original problem. When we're solving inequalities, they solve just like equations, except there's one type of problem we have to be aware of, and it's a problem like this. The very first step was that I divided both sides by -7. Whenever you divide or multiply both sides by a negative number in an inequality, you actually have to switch the inequality around for the answers to be true. So in this case, I divided both sides by -7. I should get x here, and I should get -14 as my numbers over here like I had before. But really what I have to do to make this work is I have to switch this inequality around, and really it needs to be less than or equal to -14 for to get the right answers. If I graph this, here's -14, -15, -13. It really should be a closed circle on -14, and I really want all the numbers that are less than -14, just showing that that works. -7 times negative 15 would give me would give me a positive 105, which is greater than 98. So that does check out. Those are the type of answers that I want. So whenever, again, just a kind of a general rule of thumb, whenever I multiply or divide by a negative number on both sides, I gotta switch the inequality around. Look at it, going back to example number 2 for a second. In this example, we had a negative number. We had negative 8. But we didn't have to switch the inequality around because at no time did we multiply or divide both sides by a negative number. We multiplied both sides by 5, positive 5, so that's okay. That answer, that inequality, we still solved correctly. But in number 3 here, we divided both sides by negative 7. Look at number 4, similar example. It says k divided by negative 12. So in this problem also, we're going to end up multiplying both sides by a negative number. Since I'm multiplying both sides by negative 12, it's effectively going to change the sign of both of my sides of this problem. So instead of less than, this really has to be k is greater than, and then whatever I get for my answer. So in this case, negative 11 times, or negative 12 will end up being a positive answer. It'll end up being, I think, 132. And so k is greater than 132 is what I want. I had to switch the inequality around for that to work. If I plug in a number that's greater than 132 into this inequality, that should work in this problem. Again, what will the graph of that look like? 132. There's an open circle. I can have other numbers around it. It doesn't have to be just one away. It can be anything. Okay. 130 and 134. If I pick all numbers that are greater than 132, those answers should work. Okay, just kind of showing a possible answer. Down the road here, if I kept going, I'd get to the answer somewhere down here, 144. Okay, so if I plug in 144, it should work in this inequality. 144 divided by negative 12. The original inequality is saying that needs to be less than negative 11. Okay, 144 divided by negative 12 is negative 12. Which, yes, is less than negative 11. So that does work. So I switched the inequality here correctly, and it did give me the right graph. This is what it needs to look like. Last set of examples here. Again, just because now getting into the section 6.3, solving multi-step inequalities. So when we have more than one step, or 1, 2, or 3, or 4 steps, however many it takes. Again, even these solve just like equations, which is nice. So if it helps, think about an equation like I have up there. 3x minus 5 is equal to 19. How would you solve that? It's the same steps you're going to use to solve number 1 here. Well, I would add 5 to both sides. First of all, I'd add 5 to both sides. That would cancel the 5s out over here. I'd get 3x is less than or equal to 24. Divide both sides by 3. I get x is less than or equal to 8. Here's where 8 is, here's 7, here's 9. I'm going to put a closed circle around 8. And if I want all the numbers less than or equal to 8, I'm going to shade to the left. In this case, all those answers shaded in are the potential answers to that original inequality. Again, I could even show it by picking out 7. And you could put 7 in. 3 times 7 would be 21. Minus 5 would be 16. And 16 would be less than 19. Yes, it does check out. Just showing you that these answers that I'm getting do work. So, and that's what it means. That's when I get that graph, when I get that final inequality that says x is less than or equal to 8. It's saying that any number less than 8 will work, and just showing you that they do work. Okay. Number 2. This one. We solved equations like this before. The first step we should do whenever it's possible in an equation or an inequality is distribute. So in this case, it's negative 4x, and then negative 4 times negative 6 gives me plus 24, and that's greater than 52. I got to subtract 24 from both sides. Negative 4x is greater than, what do I get over here now? 28, I think. Divide both sides by negative 4. And here's what we were talking about now, even in a multi-step inequality. We've now gotten to this part right here where I divided both sides by a negative number. So what has to happen? Well, it was greater than. On my next line of work, I have to switch that around to actually be less than to make sure I get all the right answers. So I got x by itself. but this needs to be less than, and whatever I get over here. X is less than negative 7. Again, what does that graph look like? Here's negative 7. Here's negative 8. Here's negative 6. Open circle on negative 7. And I would shade all the numbers that are less than negative 7. So if there's one thing, again, to jot down maybe about this lesson, or one more thing just to kind of have in your notes to make sure you remember, is something like, I'm going to write it here, and you should jot this down in your notes too as the last thing to mention, is those couple examples I showed you where inequalities solve just like equations, but if at some point in the problem you multiply or divide by a negative number, you will need to flip the inequality around. Need to flip, I'm going to call it, the inequality around. So if it was less than, it needs to be greater than. If it's greater than or equal to, it needs to be less than or equal to. And again, this just happens. This just happens in problems. There can be negative numbers in the problem. That's not a big deal. But it just happens if you actually multiply or divide by a negative number at some point in the problem. That's when we'll have to change it. Otherwise, inequalities solve just like equations, and they work very nice. Besides that one thing we have to keep an eye on.